Everybody, in this video, and in this physics related video we'll learn about gravity, gravitation, gravitational acceleration and some other factors. So let's get started. So when we'll talk about these factors, we have to know about the rule or law of Newton. And this rule says that every object in the universe will attract each other. That means if we have this object that will refers to object 1, and this will be our object 2, so object 1 will attract object 2 and object 2 will attract object 1. So every object will attract each other in the universe. So as they attract each other, this will be a force. And if the first object have a mass 1 m1 and the second object have a mass of m2 and they have a distance of d, so this will give us an equation, and that equation will look like this. The force between them, or the force of the attraction, will be the gravitational constant times mass 1 or m1, the mass of the first object, times m2 or the mass of the second object, divided by d square. That means the square of the distance, and this is the equation of Newton, and this will give us the force between them, or between the two objects, the first object and the second object. And the force will need the constant, that is gravitational constant. And here the g refers to, that means the gravitational constant refers to 6.673 times 10 to the power minus 11 Newton meter second reverse 2, and this is the gravitational constant. And as this is constant, this will never change. If this will never change, but the mass and the distance will change. And if you see the equation carefully, you'll see that, let me clear this. And if you see the equation carefully, you'll see that the force is proportional to the mass 1 times mass 2. That means the force is proportional to mass 1 times mass 2, and the force is proportional to 1 times d square. So when the mass will be greater, the force will be greater, and when the distance will be less, the force will be greater. So these are the basic concepts of gravitation, and you see that the gravitation exists in any two objects in the universe. But what about gravity? The gravity and the gravitation is almost same, but when one of the two objects will be the earth, this is the earth, and the other objects can be anything, suppose that is the moon, and the force or attraction between them will be the gravity. That means when in the gravitation one of the two objects will be the earth, and the earth will attract any other object. This attraction will be called the gravity. So this is the basic concept of gravity, and the equation of gravity or gravitation is almost same, but these have some difference. Let's check them. So let's check the equations of gravitation and gravity. So we'll check the difference between them. So when we are talking about the gravitation, the force is, so this will be the gravitational constant times mass 1, or mass of the first object, times mass 2 divided by d square, or the square of the distance. And when we'll talk about gravity, or the force between earth and any other object, the force will be something different, and this will be, yes, there is a g here too, that means the gravitational constant times not m1. This will be a little bit different. This will be m times the m in small letter divided by d square. So you may ask now, why the letters are different now? Why we are not placing m1 here too? Why you are placing m in big letters? So if you have understand the concept of gravity clearly, you will know that here we'll place the mass of earth in the place of mass 1 or m1. So when we are placing the mass of earth, you may understand that the mass will earth will never change. So this can be thought as a constant. So we have to think the mass of the earth as a constant. So this will never change. And when this is a constant, we have to write this in a big letter. We'll not write the m1 now, we'll write it as a constant, the m in a big letter. And we'll write the mass of other object in a small letter. We'll not write m1 or m2 here now. So here in this equation of gravity, we'll get two constants, the constant of gravitation and the mass of the earth. And as the mass of the earth will never change, so the mass of earth will be a constant. And this is the basic concept of the equation of gravity. So now we have understood the concept of gravitation and gravity. So what about the gravitational acceleration? So let's check at this. So here we have two words, gravitational acceleration. We know that the acceleration means change of velocity with time, and if you don't know about this clearly, I will publish some videos on acceleration, velocity and speed soon. You may watch them to understand this concept clearly. So now you have to understand that acceleration means change of velocity with time, and here the gravitational means it does not mean gravitation, it means gravity. So the word gravitational acceleration means change of velocity with time for gravity. And suppose we have a ground here, so this is the earth, and here is an object, and that is falling in the ground. So this will have a gravity, right? And when this will have a gravity, this will fall in the ground. And when this is falling in the ground, it will get some velocity. and the velocity will change with time, right? So when the velocity of this object is changing with time for gravity, the change of velocity will be called gravitational acceleration. And this is a very interesting concept. So what will be the acceleration, or how can we count the acceleration of this object for gravity? So we know that if I am talking about F in for gravity, not for gravitation, and F means G times m by d square, and this is the equation for gravity, right? So let's keep it here now. And we know from the law of Newton that F or force means mass times G. What is G here? And this means the gravitational acceleration. And from this law, we know that the gravitational acceleration is the G, or the G in small letter, and the G in big letters or larger letters will mean the gravitational constant. And when this is in the letter in small letter G, this will refer to the gravitational acceleration. And from these two equations we can know what is G, or how can we calculate the G. So from these two equations, let's replace the force or F here with the mg, because the force means m times g, or mass times gravitational acceleration. So we can easily replace the force here with mass times gravitational acceleration, and this will give us this. So mass times gravitational acceleration means gravitational constant times m, or the mass of earth, and the mass of the other object times divided by d square. And from this equation we will get the equation for G, and this will give us this. The G will be gravitational constant times the mass of earth by d square, and this is the equation for gravitational acceleration. And if you look at this equation carefully, you will see that the gravitational acceleration does not depend or depend on the mass of the other object, that means the m. So this will give us another important and is what also this is a very interesting fact, and that is, so this equation gives us an interesting fact, and that is, if we have two objects, suppose the first object have a mass of 10 kilogram and the second object have a mass of 1 kilogram. So this object is heavier than this, right? And this equation gives us an interesting fact that if you think that this object that is heavier than the other will fall faster than the other object, you your thinking is wrong. And because the acceleration does not depend on the mass of these objects, it only depends on the gravitational constant, that is a constant, on the mass, that is also a constant, mass of earth, that is also a constant. That means the gravitational acceleration does not depend on these two factors, because they don't change. These are a constant, and the gravitational constant only depends on the distance of the objects from the center of the earth. That means the distance is not the distance from the ground. This this refers to the distance from the center of the earth. And if an object is here, the distance from earth to this object will be the distance from this to the center of the earth. And this d can be changed with r, that means radius, because when the distance from the center is the d, the d can be changed with r, because this is really the radius of this. This is actually the radius of this circle, right? If you have a keen eyes, you will see that this distance is really the radius of this circle. And so we can rewrite this equation with this: gravitational acceleration is gravitational constant times mass of the earth divided by r squared. And this is actually the equation for gravitational acceleration. So till now, whenever we have talked about m, or the m in small letter, m1 or m2, that means the mass of an object, you have to remember these are the mass of object, not the weight. So what is the difference between mass and weight? So when you're talking about mass and when you're talking about weight, always remember these are not a same factor. These have a lot of difference between them. So mass is a constant. Why this is a constant? Because mass is the total amount of matters in an object. So suppose this is an object, and the total amount of matters in this object will be the mass. So what will be the weight now? When you're talking about weight, this will be mass times J, mass times gravitational acceleration. That means the force we get from the law of Newton was mg, and this F is actually the weight. So the weight is a force, and these are the and the unit of weight is Newton, because the unit of force is Newton. So when we can replace the force with weight, so the unit cannot be changed, the unit will be same. So the unit of weight is Newton. So the mass is a constant and the weight is not a constant, because we have two factors here. One is the mass and other is the gravitational acceleration. So the mass is a constant, so the weight don't depend on this. So this will depend on the gravitational acceleration. And gravitational acceleration can be changed with place and with time. So from this two factors, we can now understand that when we are talking about our daily shopping list, if you say that you have some potatoes, suppose you have 1 kilogram of potatoes, so you have 1 kilogram of potatoes, and if you say that the weight of the potatoes you have is 1 kilogram, you are wrong, because The weight cannot be calculated with the unit kilogram. This have to be calculated with the unit Newton, and the Newton is the unit of force, so the weight is a force but the mass is not. So you are fully wrong when you're talking this. So thanks for watching this video, and this was the first part of the our factors we have discussed in this video. And if you have watched the whole video carefully, you have learned about gravity, gravitation, gravitational acceleration, mass, and weight. So I hope that you have enjoyed this video, and if you have enjoyed this really, please subscribe this channel and please like, share, and comment my video. And this is a fully new channel. Your one like will help me to grow 10%, and this is the real truth. So please like, share, and subscribe. And if you have any question, please put a comment below, and I will answer all of your question as soon as possible. So thanks for watching. Again, please follow my playlists to watch my next videos first. Thanks for watching again.